The evolution of agriculture is explored, highlighting how vertical farming technology is poised to redefine food production. The advancements that are enabling sustainable and localized food systems for a burgeoning global population are showcased. The crisis we're growing into is the unsustainable trajectory of feeding a growing global population on a finite planet, driven by shrinking arable land and agricultural practices that degrade the environment. While global population continues to grow, creating more demand for food, industrial agriculture depletes water resources, pollutes with pesticides, and contributes to greenhouse gas emissions through intensive methods and long-distance food transportation. This unsustainable cycle threatens food security, biodiversity, and the stability of ecosystems upon which all life depends. The global population has grown significantly, from 1 billion in 1800 to over 8 billion in 2025, with projections for further growth to around 10.3 billion by the mid-2080s. The demand for more food necessitates agricultural expansion, which leads to the conversion of forests and wetlands into farmland, resulting in habitat loss and a decline in biodiversity. This increased agricultural demand, combined with population growth and industrialization, places intense pressure on finite resources like water, soil, and land. Agriculture is a major consumer of freshwater, and unsustainable practices worsen water scarcity, a significant issue, particularly in drought-prone areas. Intensive farming methods often rely on heavy use of pesticides, which can contaminate water sources and harm ecosystems, threatening biodiversity and human health. Agricultural land and the widespread use of fossil fuels for farm machinery and food transportation contribute to CO2 emissions, further driving climate change. Modern agriculture, particularly the focus on a few high-yield staple crops, is a primary driver of biodiversity loss, threatening the stability of the planet's ecosystems. The combination of resource scarcity, climate change impacts on agriculture, such as erratic weather patterns, and unsustainable farming practices intensifies food shortages. The destruction of natural habitats through agricultural expansion leads to the loss of vital ecosystem services and increases the rate of species extinction. Agriculture's large environmental footprint exacerbates climate change, which in turn creates more severe climate conditions that further disrupt agricultural production. The looming food security challenge stems from a combination of climate change, geopolitical instability, growing population, and resource depletion, which threaten crop yields and food supply chains. This crisis demands innovation in the food system to create more sustainable and resilient agricultural practices. Innovations include precision agriculture, the development of alternative protein sources and functional foods, and new food production technologies like nanotechnology, which can increase food output while minimizing environmental impact. Worsening climate conditions are a major driver of food insecurity, impacting crop yields and increasing the risk of food crises. A growing global population, expected to reach 9.7 billion by 2050, creates unprecedented demand for food that traditional farming methods struggle to meet. Geopolitical conflicts, poverty, and economic shocks are significant factors that contribute to acute food insecurity, especially in vulnerable communities. The strain on natural resources, such as land and water, due to rapid urbanization and industrialization, coupled with significant food loss and waste, further exacerbates the problem. Current food systems contribute significantly to climate change through greenhouse gas emissions, deforestation, and high freshwater usage, creating a vicious cycle. Innovations in agriculture, such as precision agriculture using GPS and sensors, help optimize resource use and increase crop yields. Research into alternative protein sources and functional foods, along with the use of nanotechnology in food science, offers new possibilities for future nutrition and food security. A coordinated global effort involving policy changes, scientific research, indigenous knowledge, and local action is crucial to build more equitable and resilient food systems. 1/3 of all food produced is lost or wasted, highlighting the critical need for improved infrastructure and practices to reduce this loss. Vertical farming's immediate benefits of massive space efficiency, year-round harvests, and reduced water usage are made possible by key enabling technologies like LED lighting spectrum control, hydroponics/aeroponics/aquaponics for soil-less growing with nutrient-rich water, and climate control systems for optimizing temperature, humidity, and other environmental factors. These technologies create controlled, indoor environments that allow for consistent, localized food production with significantly less land and water than traditional agriculture. Advanced LED lights can be programmed to emit specific light spectrums, providing plants with the precise wavelengths they need for optimal growth at different stages, improving efficiency and crop quality. Vertical farming allows for crops to be grown in layers, significantly increasing the yield per square foot compared to traditional farming, making it ideal for urban environments. Hydroponics, plants are grown in water-based nutrient solutions, often with an inert growing medium. Aeroponics, roots are suspended in the air and misted with nutrient solutions, using less water than hydroponics. Aquaponics integrates aquaculture, fish farming, with hydroponics, where fish waste provides nutrients for the plants, and the plants filter the water for the fish. Hydroponic farming is a method of growing plants without soil, using water-based nutrient solutions to provide plants with the essential nutrients they need to thrive. Instead of soil, roots are either directly exposed to the nutrient solution. Aeroponics is a soilless farming method where plant roots are suspended in the air and regularly misted with a nutrient-rich solution. Unlike hydroponics, where roots are submerged in a water nutrient solution, aeroponics uses an airy, misty environment to deliver nutrients directly to the roots. AI-powered robotics is revolutionizing agriculture by automating tasks like planting, weeding, and harvesting with precision, while also optimizing plant growth through data-driven irrigation and pest detection systems. These technologies address labor shortages, increase efficiency, reduce waste, and promote sustainability by minimizing the use of pesticides and water, ultimately enhancing crop yields and quality. Smart farming utilizes the Internet of Things, IoT, through connected sensors and AI-powered predictive modeling to optimize yields by collecting real-time data on soil conditions, weather, and crop health. Sensors monitor soil moisture, nutrient levels, and weather, feeding data into AI models that forecast outcomes, enabling data-driven decisions on irrigation, fertilization, and pest management. This integration reduces resource waste, improves efficiency, lowers operational costs, and increases crop yields and sustainability. AI-powered automation and robotics are revolutionizing farming by enabling autonomous machines, drones, and sensors to perform tasks like planting, harvesting, weeding, and crop monitoring with precision. These technologies use machine learning and computer vision to analyze data, optimize resource use, and adapt to changing conditions, leading to improved efficiency, reduced labor costs, increased yields, and more sustainable farming practices. Automation handles repetitive and physically demanding tasks, freeing up human workers and increasing overall operational efficiency. AI-powered systems identify and eliminate weeds and apply targeted herbicides, minimizing chemical use. Drones and sensors collect real-time data on crop health, soil conditions, and nutrient levels, allowing for early disease detection and precise interventions. AI-powered drones. Used for crop monitoring, land surveying, and precise application of treatments. Addressing food deserts involves creating hyper-localized food systems through urban agriculture, community gardens, farmers markets, and mobile markets to ensure fresh, affordable produce is accessible, especially in low-income areas. These initiatives also support community well-being, improve access to healthy food, reduce transportation costs, and foster resilience against food system disruptions. Innovative techniques like hydroponics, aeroponics, and greenhouse farming can boost production in urban environments. Successful vertical farms globally, such as freight farms in urban areas like Miami, demonstrate diverse applications from providing fresh produce to food-insecure communities to enabling local food production in remote locations through containerized systems. These farms excel at growing leafy greens, herbs, and microgreens with high water efficiency and reduced pesticide use. A burgeoning industry with potential for economic revitalization and new green job creation refers to the growing green economy, which drives economic prosperity through investments in sustainable technologies like renewable energy and energy efficiency. This leads to increased demand for a skilled workforce in areas such as solar panel installation, environmental management, and sustainable agriculture, creating numerous job opportunities and fostering economic growth. This refers to industries focused on renewable energy, resource efficiency, and sustainable practices, which are essential for a transition to a sustainable and inclusive economy. Jobs are created in direct areas such as manufacturing, installing, and maintaining renewable energy technologies like solar panels and wind turbines. The term burgeoning implies that the industry is rapidly expanding and evolving. This refers to industries focused on renewable energy, resource efficiency, and sustainable practices, which are essential for a transition to a sustainable and inclusive economy. The expansion of green industries spurs innovation and creates new economic opportunities. Governments and private investors are increasingly directing resources towards green technologies and sustainable infrastructure, which boosts economic activity. Jobs are created in direct areas such as manufacturing, installing, and maintaining renewable energy technologies like solar panels and wind turbines. Opportunities arise in supporting sectors, including sustainable agriculture, waste management, and the design of energy-efficient buildings. Harvesting Tomorrow describes a futuristic food system focused on multi-crop vertical farms that integrate with aquaculture for a symbiotic, resource-efficient food cycle and deliver personalized nutrition to consumers, creating a more sustainable and resilient agricultural future. This system aims to overcome land limitations in urban areas, reduce food waste, minimize environmental impact, and provide healthier, locally grown food year-round. Urban and indoor cultivation growing crops in multi-layered systems within buildings, maximizing land use in urban environments. Controlled environments optimizing temperature, humidity, lighting, and CO2 levels for ideal crop growth and increased yields. Resource efficiency significant reduction in water usage and elimination of pesticides, making farming more sustainable. Expanded crop variety moving beyond leafy greens to cultivate a wider range of fruits and vegetables through advanced breeding and new growing mediums. To address the high energy consumption and setup costs in vertical farming, solutions include integrating renewable energy, optimizing LED lighting, and designing efficient systems that reuse heat. Scaling for wider adoption requires collaborative efforts among researchers, policymakers, and industry to develop innovative financial models and advanced automation, ultimately leading to more sustainable, resilient, and equitable food systems by bringing food production closer to consumers and reducing resource dependency. It drastically reduces water and land use, lowers reliance on pesticides, and minimizes the carbon footprint by shortening supply chains and enabling urban production. By collaboratively tackling energy and cost challenges and leveraging technological advancements, vertical farming can transition from a niche practice to a mainstream solution, building more robust and equitable local food systems worldwide. Foster collaboration between researchers, policymakers, and the industry to create supportive regulatory frameworks and promote best practices. Invest in advanced automation and data analytics to enhance efficiency and reduce operational complexity, making the technology easier to manage on a larger scale. Integrate renewable energy sources to power operations, reducing reliance on conventional energy grids. Use energy-efficient LED lighting that produces less heat.